DC motor converts electrical energy into mechanical energy. So next is a transformer. So transformer is a device which only changes the alternating voltage. It only changes the alternating voltage. Okay, so इसको हम ऐसे definition लिखे. It is a device which is used to change mean either we can increase or decrease the alternating voltage. So it is a device which is used which is used to change mean either we can increase
or decrease
the AC voltage, alternating voltage only. Alternating voltage.
Yeah.
So transformer is a device which can increase or alternating voltage. Any confusion in the definition?
No, sir.
Next is, what are the main parts of the AC generator? Transformer. तो बेसिक हम पहले लिखते हैं कि what is the basic principle? What is the principle of AC transformer? So it based upon the principle of mutual induction. What is mutual induction? ये अभी आपको एंड पे पता चल जाए क्या होती है. Next is the main parts or construction of the transformer. The next is construction. So transformer consists of three main parts. First one is a transformer. A transformer consists of three main parts. Any idea?
No, sir.
No. So first one is primary coil. Is secondary coil. And the third one is laminated soft iron core. Third one is laminated soft iron core. तो डायग्राम में अगर आप देखें, this side, this coil is called primary coil. Okay, this one is the primary coil where we apply, or it is connected with the AC supply, जहाँ से हमने input apply करनी है. And the other coil which is in the form of green color, this is called secondary coil where we load just like bulb. Okay, any confusion?
No, sir.
So we have two coils. First one is primary coil where we apply the AC source, and the second one is the secondary coil which is connected with the load, resistors, or maybe any device. So input is taken to the primary coil while output is taken across the secondary coil, and in center it is a soft laminated iron core. ये जो आपको ग्रे कलर में नजर आ रहा है, this one is the core of the transformer. Basically it provides the path to the magnetic lines to move from primary coil to secondary coil. So why we use a core? Because it provides the path lines to move from primary coil to secondary coil. Okay, so basically core provides the path for the magnetic lines to move from primary coil towards the secondary coil. So first one is primary coil. Primary coil is connected to a AC supply. Is connected with AC supply. AC supply mean input is taken to the primary coil. Input is taken to the primary. Next one is secondary coil, which is connected to the output circuit. So it is connected to the output circuit. So output is taken across secondary coil. Next is the laminated soft iron core. So it consists of different iron sheets. Different iron sheets. It is in the form of strips. So it consists of different iron sheets separated insulating medium. Separated by insulating medium. Any confusion?
No, sir.
So this one is the primary coil, secondary coil, and in between we have iron core, which is in the form of strips. और इसको हम लिख लेते हैं कि why we are using laminated iron core, because it provides the path to the magnetic lines to move from primary to secondary coil. And why we are using the soft iron core? Why we are using the soft iron core? इसको भी हम नीचे कर लेते हैं. The soft iron core is used because it can be easily magnetized. Soft iron core is used because it can be easily magnetized and demagnetized. So any confusion in these points?
No, sir.
Easy.
Yes, sir.
Any confusion?
No,
Okay, how you, man?
not good, sir.
Okay. Next is so we have three main parts of the iron core transformer. First one is the easy. We have started transformer, and you know that transformer is a device that only used to change mean increase or decrease the alternating voltage. Okay, and principle is it based upon the principle of mutual induction. Next, construction. We have three main parts of the transformer. First one is the primary coil, which is connected with the AC supply, means input is taken to the primary. And secondary coil is the second part. which is connected to the output circuit means output is taken across the secondary coil. Next is laminated soft iron core. These two coils are wound on the iron core strips. Okay, and it consists of different iron strips or sheets separated by insulating medium. Basically, we are using the core because it provides the path to the magnetic lines to move from primary to secondary coil. And the last, why we are using soft iron? Why we are not using just iron that it is soft, should be soft iron? Because soft iron is a soft magnetic material and it can be easily magnetized and demagnetized. Any confusion?
No, sir.
Next is working, how the transformer works. तो हम हेडिंग दे देते हैं वर्किंग, इसको हम ना पॉइंट्स में लिखते हैं. सो फर्स्ट पॉइंट इज कि वी फर्स्ट सप्लाई द इनपुट करंट टू द प्राइमरी कॉइल. तो हम ऐसे लिखते हैं द ऑल्टरनेटिंग करंट सप्लाई टू द प्राइमरी कॉइल. द इनपुट alternating current, the input alternating current supplied to the primary coil. कि सबसे पहले हमने इनपुट किसको देनी है? प्राइमरी कॉइल को. फ्रॉम द पावर सोर्स. So the input alternating current supplied to the primary coil from the power source. कि सबसे पहले तो हम वहां से इनपुट अप्लाई करेंगे टू प्राइमरी कॉइल को. When we are applying the input voltage, then what will happen? Any idea?
So can you repeat?
When we apply the input voltage to the primary coil, then what will next happen?
It'll go around the things and then produce.
Okay, the magnetic field produced. So due to the current, the magnetic field produced by the primary coil, ठीक है, क्योंकि ड्यू टू दिस करंट द मैग्नेटिक फील्ड विल प्रोड्यूस बाय प्राइमरी कॉइल and this magnetic field is continuously changing, and this magnetic field is continuously changing. Any idea why the magnetic field is continuously changing?
Because alternating currents.
हाँ जी, because the current is AC due to the alternating current. So first point is, first we apply the alternating current to the primary coil from the battery or power supply. Due to this current, magnetic field is produced around the primary coil, and this magnetic field is continuously changing. So due to this change in magnetic field lines, because the secondary coil is placed very near to the primary coil, the magnetic field lines of the primary coil also passes through the secondary coil. That's why the EMF will induced in the secondary coil also. तो अब हम थर्ड पॉइंट ऐसे लिखते हैं. Third point is the magnetic field lines. The magnetic field lines. The magnetic field line through soft iron core passes through soft iron core and through the secondary coil and through the secondary coil. Okay, because we have, for example, this is a core of the transformer, central core of the transformer, and one side there is a primary coil and the other side we have secondary coil. Okay, so the primary is connected with the AC and secondary is connected with any electric bulb. So when AC is supplied to the primary, the magnetic lines of the primary coil move through the core and also passes to the secondary coil. इस तरह से ये मूव करेंगी. अब देखें मैग्नेटिक लाइंस जो हैं वो सेकेंडरी में भी पास हो रही हैं. सो ड्यू टू द चेंज इन द मैग्नेटिक लाइंस the EMF induced in the secondary coil. So next point is the field lines in the secondary coil. The magnetic field lines. The magnetic field lines in secondary coil. Secondary coil, which comes from the primary coil. The magnetic field lines in secondary coil EMF induces EMF by the phenomena called electromagnetic induction. Electromagnetic induction. So the first point is the input alternating current supplied to the primary coil. First we supply the alternating current to the primary coil, then magnetic field produced by the primary coil. So magnetic field will produce around the primary coil, and this magnetic field is continuously changing. The current is alternating. Now these magnetic lines passes through soft iron core and also through the secondary coil. After that, the magnetic field lines in secondary coil induces EMF, because according to Faraday's law we know that whenever there is a change in magnetic field lines or whenever there is a change of magnetic flux, an EMF will induce in the coil. Next is the last point is the EMF produced in the form of alternating current. The EMF produced in the form of alternating current. Yes, this is the working of.
Sir, can you repeat all that?
Okay.
My Wi-Fi was very lag.
Okay. So the first point is the input alternating current.
No, sir. The point you just said.
Which point?
Sir, job abhi likh rahe the.
Okay. The EMF produced in the form of alternating current. Okay. The EMF produced in the form of alternating current. So any confusion in these points? Yes. Okay. Next is, so we have a primary coil The current in the primary coil is denoted by IP. IP is the current in the primary coil, and VP is the induced voltage in the primary coil, and NP is the number of turns in the primary coil. Same with the secondary coil, we just write IS, current in secondary, VS, the induced EMF in the secondary, and NS is the number of turns, mean number of जो loops हैं उसको हम number of turns कहते हैं. So these are the basic symbols. Now according to Faraday's law, we know that last time we have done Faraday's law, which is the EMF induced in any coil is directly proportional to the rate of change of flux through that coil. By यहाँ पे मैं लिख देता हूँ, by Faraday's law we have, by Faraday's law we have, Faraday's law is the EMF induced is directly proportional to the number of turns and the rate of change of magnetic flux. Flux means the flow of magnetic lines. This is the Faraday's law. Now in case of primary, the EMF induced in primary coil is VP. VP is the induced EMF in the primary coil, and the number of turns in the primary coil is NP, whereas delta phi over delta T is the magnetic lines passing through the primary coil. This is our equation number 1. So we just use the Faraday's law and just changing the symbol, not changing the symbol, just we write P with the subscript. Okay. Similarly with the secondary coil, similarly we have VS, the induced EMF in the secondary coil. The number of turns in the secondary coil is NS, and delta phi over delta T is the rate of change of the magnetic flux. So we just use the Faraday's law and just placing the symbols for primary and secondary. For primary we use P in the subscript, and for secondary we use S in the subscript only. Any confusion, Ryan?
No, sir.
Now dividing equation 1 and 2, so we get, so when we divide them, so on left side we have VP over VS, on the other side we have NP delta phi over delta T, and in denominator we have, in numerator we have NP. Numerator we have NP delta phi over delta T, and in denominator we have NS delta phi over delta T. So delta phi over delta T, delta phi over delta T will be cancelled. So we have VP over VS, VP over VS is equals to NP over NS. So this is our first transformer equation. इसको मैं equation number A कह देता हूँ. So this shows that greater will be the number of turns, the greater will be the induced EMF, either in primary or either in secondary. Mean when you are increasing the number of turns, the induced EMF will also increased. Any confusion?
No, sir.
Next is,
No, sir.
for ideal transformer, for ideal mean whose efficiency is 100%. For ideal transformer, ideal mean whose efficiency is 100%. So the power, input power and output power are equal. ठीक है. It is only for ideal one. So in ideal, input power and output power are equal. So for power we use P, and the input is given across primary, so I just write power across primary, okay? And output power is PS, means output power is taken across the secondary coil. And what is the formula of yes, easy. The simple first formula for power is
P equals E over T.
good. P is equals to E over T, and then IV.
I square.
Yes, IV, I square R, V square R. So here we use only the IV. Very good. So for primary, we use P in the subscript, and for secondary, we use S in the subscript. Okay. Now we just rearrange them.
Sir, I'm sorry again, can you explain yes sub again because my Wi-Fi stopped working?
Okay, it is just recording. तो मैं आपको ये शेयर कर दूंगा. No issue. Okay.
Okay, sir. Thank you so much.
Repeat कर देता हूँ. So for ideal transformer, we just dealing with the ideal transformer. In ideal transformer, the input power is equals to the output power. Input power is equals to the output power. So input power is given to the primary and output is taken across the secondary. So for power we use symbol P, and the formula for power is P is equals to IV. There are so many formulas, but we are using IV here. So for primary we use P in the subscript, and for secondary we use S in the subscript. Okay, now rearrange them. देखिए VP यहाँ पे लिखा हुआ है, so हम इधर शिफ्ट करेंगे, so it will be divided. So VP over VS, VP over VS, and on the other side we have IS over IP, IS over IP. We just rearrange them. VS move to the other side, IP move to the right side. So this is our equation number B. Now compare equation A and B we have. So देखें, equation A थी VP over VS. VP over VS is equals to NP over NS, and also VP over VS is also equals to IS over IP. So अगर करके लिखें, so we have combining equation in general form बना देते हैं. So in general we have comparing equation A and B. So we have VP over VS, which is equals to NP over NS, and it is also equals to IS over IP. So it means, for example, we just consider the primary. By increasing the number of turns in the primary, तो उसकी EMF भी increase हो जाएगी, लेकिन उसमें करंट क्या हो जाएगा, decrease हो जाएगा, because with current there is a inverse relation now. So if we increase the number of turns in the primary, so induced EMF in the primary also increase, but due to the inverse relation, the current in the primary will decreases. Same with the secondary coil. So it means what we are doing in the transformer, we increase the voltage and then decrease the current. So in transformer the basic principle is we are increasing the voltages and decreasing the current. So by decreasing the current, heat losses reduces. Heat loss reduces. So जब heat loss reduce होगा, so we can transfer the voltage over the long distance. This is a basic principle. So in transformer, we increase the voltage and decrease. Now by decreasing the current, the heat losses also reduce. So as a result, we can transfer the voltage over the long distance. So any confusion now?
So, no, sir.
Okay. Next is types of transformer. There are basically two types of transformer. First one is step down and the second one is step up transformer. Step up mean which is used to increase the voltage, while step down is used to decrease the voltage. और अगर आप इसमें चेक करें इन sorry diagram, this one is for this one is for step up and this is for step down. Okay, so step up is which is used to
So in step up give more voltage, so isn't that one the one with more turns at secondary coil?
oh yes
Isn't that
yes
step up?
yes sorry my mistake. So this one is the step up, good, and the second one is okay, diagram is correct, sorry. Step up is used to increase the voltage while step down is used to decrease the voltage. And how we can increase the voltage? If this is the secondary coil and the number of turns in secondary coil is ns and the number of turns in the primary coil is denoted by np. So if the number of turns in the secondary coil is greater than the number of turns in the primary coil, so we prove that greater the number of turns, the greater will be the induced EMF. So Vs should be greater than Vp. Okay, so by increasing the number of turns in the secondary coil, the secondary EMF will also increased. This is called step up transformer. Okay, whereas current have inverse relation. So the current in primary is greater than the current in secondary. By increasing the number of turns, we increase the by increasing the number of turns, the induced EMF also increase but current decreases. Whereas exactly reverse, in step down transformer, the number of turns in primary is greater than number of turns in secondary, whereas the induced EMF in primary is greater than the induced EMF in secondary. So the current of secondary increases as compared to the current in the primary. So this is the transformer topic.